Hello everyone, welcome to the second part of the Chapter 11 videos, where here we're going to be covering section 11.2 where we're talking about still the inferences about two different samples possibly coming from two different populations, but now we're doing the means instead of the proportions like in section 1. So the main difference there is going to be that means always concern the sample statistic, or the test statistic rather, that's the t-value. And so we're going to use all of the same kinds of calculator buttons, but we'll use the t version. So instead of doing a z-test, or in the case of two proportion z-test, we're going to be having something like two sample t-tests, looking at those t intervals, keeping t in mind whenever we're talking about means. Now, there are two different approaches for doing it with means, because it's possible to have, now using some of the terminology from previously in the semester, we're still talking about dependent versus independent, and in terms of sampling here, what we're referring to is the idea that whenever we're doing the inferences with two means, it's possible to have independent samples where the samples for group 1 and group 2, as it were, or else, in the case of an experiment, maybe you have an experimental group and a control group. Either way, you're having two different samples and you're getting some statistics from two different samples. Those samples, they might be independent from each other, where whenever the sampling method is independent, it means that the individuals that are selected for one group have no bearing and do not affect anything about the samples that are going to be in the second group. However, with the dependent samples, what that means, dependent as in completely dependent, 100% dependent, also we use this word matched pairs. And what that means is that whenever an individual is selected for one group, that actually by itself, that determines the corresponding individual that's going to be in the second group. And so sometimes this might be the same individual. This might be like a before and after on the same individual. And another possible, I'm meaning to say here, on the same individual. And then this could also be maybe like married couples or something. Because of course, if you pick the husband for group 1, then for sure you're picking his wife for group 2. This could be like married couples, or maybe identical twins or something like this. We might do an experiment with twins. So if twin A is in the first group, then for sure his twin is going to be in the second group. That's going to be called the dependent sampling in this case, which also is referred to as matched pairs. Now, whenever we have matched pairs, we can take a special approach to this because we will know a couple of things. One of them being that the sample sizes will be the same. And the second being that we're actually interested not in just comparing the means, but we can take the data and just find all the differences. Find, in the case of before and after, we could find the difference between the before and after since we're talking about the same individual. And we're actually going to do that here. We're going to, instead of thinking about this as being two different groups or two different means that we're comparing, what we would do is take the data sets, take the data that's for the one group and the data that's for the other group, and then we would just make a third list of data that just contains the differences. The difference of the individual from group A, or else the statistic from group A and the statistic from group B, we would just find the difference. And we're going to use a symbol for that, which is going to be this lowercase d. That's a difference from group 1 and group 2. Once we have that list that contains all the differences, we will have this d bar, which is the mean from that list. We can have the s sub d like this, which is the standard deviation from that list, and so on and so forth. And the hypothesis structure for this one, since we're going to be talking about just one group of data, even though we started out with two lists of data, we're going to just turn it into one by making the differences. And then what we are going to use as the null hypothesis is that the average of the differences is just 0. So that's kind of like saying no difference. On average, there is no difference between group 1 and group 2. And then, depending on the context of the problem, we might want to be looking at two-tail versus left-tail versus right-tail test. And then we have something that I mentioned from the section 11.1, where we were talking about doing this with proportions. We can do it with the means as well. We can interpret the context. Based on the context, we can interpret this kind of a thing. If the average difference is greater than 0, then what that means is that the average for group 1 is more than the average for group 2, because here the average of the differences is actually the same thing as the difference of the averages. So the average difference, that's the difference of the averages, and if this thing is greater than 0, then we could simplify this inequality around, get this kind of a situation that the mean for group 1 is more than the mean from group 2. And so it's not going to be a problem that we're just changing this into one list of data. But anyways, we're going to use a t-test for this because we don't effectively have two different samples. We're having our two samples turned into one sample by just making it a list of differences. But we'll see an example for this problem. And we're going to be looking at number 8 that's on the test 4 review, where here we are comparing for each individual, the arm span versus the height. And so basically this statistics student, they're checking whether, we need to see in the context here what they're trying to measure, but we're looking for, is there just any difference at all between the height and the arm span. So we don't care if the height tends to be more than the arm span or vice versa. We're just looking for whether there's a difference. And the idea is that since we're just looking for any kind of a difference, then in our alternative hypothesis, we're going to be doing a two-tailed test where there's just any difference. And so basically we're checking whether the average difference is something other than 0. If it's something negative, then we could say perhaps that the arm span tends to be more than the height, or if it's something positive, we could say that the height tends to be more than the arm span. But here we're not trying to go one way or the other, we're just trying to say that there's a difference. But since this one we're using, of course, we had somewhat of a prelude to the fact that this is going to be a dependent sampling case where we're looking at the mean difference. But what we could tell, is that for each individual, we're taking the arm span and the height of the same individual. And so this would be a dependent kind of sampling, because whenever we get the height from an individual, we're actually using the same individual for the arm span. And so that's why you would call it matched pairs. In this case, it's one of the ones where it's not actually two different individuals. It's the same individual, but we're just measuring two different statistics about them, and we're going to pair up those data. And so the height of 59.5, it goes with the arm span of 62 because they're from the same individual. It's a dependent sample, which means we are investigating the mean difference. And the null hypothesis should go that the mean difference is 0, means that there's no difference between the height and the arm span. But what I'm going to do is I'm going to go into my calculator, to the stat and the edit, and I am going to enter these data into list 1. I don't actually have a list 2 anymore. I deleted it somehow, but list 1 and list 3 is what I'm going to put these into, and then we'll see how to proceed. And now I have in list 1 all of the heights, and in list 2 all of the arm spans. And of course the order is key here, because these data are supposed to match up with each other. And actually you would see that if we jumbled up the order, it's not going to really affect our outcome, but it would affect our interpretation whenever we're looking at this thing. But anyways, in list 4, which is probably for you, you're using list 3 right here, but if we highlight the name of the list in the calculator, we go list 4 like this, when we press enter, it gives us our cursor so that we can put in a formula for list 4. What we want it to be, I'm going to write down what we're going for this one. List 4, we want it to be the differences of the number from list 1 and the number for me it's list 3. That's where my arm spans are. And so it's going to be taking basically a height minus an arm span, and it's doing it by pairs like this. And that's what we can actually put into here. We can go second one gives us list 1 minus list 3, and then when we go enter, see, it's going to populate this list with all the differences of the first number minus the second number. And you can see whenever one of these numbers is negative, it's because the height was less, and whenever the number is positive, it's because the height was more than the arm span. But we have now our list of differences, so I'm going to quit out of that one, and then I'm going to go into stat. We want to run a test because we're doing a t-test for this one. And we're working with, in this case, the data, because we actually have the specific data sets with the numbers in there, and those are in list 3 are where the data of interest are. No, not list 3, it's list 4 for me, because I made list 4 be the set of the differences. And then the mu naught that's over here, that's going to be 0 because that's this value that's from the null hypothesis is the mu naught at 0. And we are checking the two-tailed case, just whether the mean difference is something other than 0. So we'd pick the not equals, and then we'll go over here and we'll calculate it. And we're looking at the test statistic, which is the t-value, and also the p-value to try to make this decision. I'm going to refer to the p-value, which is 0.62. Now, if we were going to carry on doing this by the test statistic, we need to look at the table and figure out what the critical t-value is to find the critical region and see whether this t-value is inside the critical region or not. But with the p-value approach, we just very simply, we're comparing our p-value to the alpha, which is the level of significance, and since it's more, it's actually a lot more than the alpha value of 0.05, in that case we can do not reject the null hypothesis. If it were the p-value were less than 0.05, then we would reject the null hypothesis, conclude that there is, or at least that we would say that we found evidence that there is a difference in the height and the wingspan. Since we're not rejecting, we are basically saying that we did not find any evidence to conclude that the height and the wingspan are anything different. Or else, there's so many ways to phrase this conclusion, that's kind of the idea. You would want to phrase that we're not rejecting the null hypothesis in terms of heights and wingspans. Now we will try doing this again using the confidence interval approach, kind of like we did with the proportions. We could actually come here and make, going to stat and tests, we can make a t-interval. We're still making the t-interval from data because our data are in list 4. Our confidence level, we need to make it as 95% confidence level and calculate this one. And that confidence interval is going from negative 2.176 up to 1. I'm just going to round them both to 3 decimal places, 1.367. And that's our confidence interval. This is supposed to be an interval for, this is for the mean difference. Now this mean difference that we have, it's straddling 0. You notice it's going from, here's 0, it's going from negative 2 point something up until 1.3. And so the value of 0 is in that interval. Basically the conclusion, what we're seeing is that, well, and we're doing here height, the difference is, we subtract in this order the height minus the arm span. And so in the left case where it's going negative 2, if that's the mean difference, then what we're saying is that the arm span is greater by 2 inches. But if we take the right bound, that's saying that the height is more by 1.367 inches. And so we're basically, our interval is saying that the height might be more or it might be less. And that's why we have to conclude that there's not enough evidence to say that the height is different from the arm span. We would conclude that they're probably just the same. But anyways, that does it for the section 2 video where we're talking about basically the dependent sampling case. We'll see in 11.3 we're going to talk about whenever the samples are independent, and that will bring us into some other calculator buttons that we're going to use. But anyways, I hope this video was helpful, and I'll see you guys in the next one. Thanks.